So on behalf of Struct Soft Center, I would like to welcome to all of you in this introductory session of upcoming live training program under the title of Professional Approach for the Design of Foundation using CSI SAFE Excel along with Manual Approach. So before of starting this introductory session, some instruction you all have to follow. Like during delivering this session, don't ask any question. Whatever your doubts and queries are there, just write in the chat box. If I feel it is important to answer, I will try to answer at that time. Otherwise, we will take some time at the end of this session for doubt clarification to resolve all your doubts and your questions. We will take some time. So it's a request with you all guys, don't ask any question in between of my discussion. Second thing, kindly write your name and contact number in the chat box so that later on we can contact with you. So finally we are going to start this introductory session, and here we have to understand what we are going to learn in this training program. And in the first 5 to 10 minutes we are trying to understand why you should have this training program and how this training program will help for the participants, for the students who want to work as a structural engineer and who want to design the foundation, not only to design but also if you want to schedule it, if you want to detail it, how to do this, and how this training program will give the real exposure of the real practice. That all things we will discuss in detail. So very basic things, some basic things might be known to all of you, that what if you are talking about any structure, so a structure will be subjected of two parts. One is your superstructure and substructure. This basic thing that might be known to you. And another important thing, you all know that the structure, the load transfer mechanism. So the load is transferring from top to down. In gravitational load is going to be distributed. So whatever the load is at your superstructure, that is going to be transferred to your substructure. That is going to be transferred to the foundation. And it's a myth in our mind that the foundation is carrying the load, but that is what totally wrong. Your foundation is not going to carry the load. Your foundation is responsible to transfer that load to the subsoil. So it's confusion, it's a myth in our mind that substructure means your foundation. No, substructure is not only your foundation, it includes also the subsoil. So foundation plus subsoil will combinedly give you substructure. And here we are not going to design the foundation to carry the load of the superstructure. We are designing the foundation to transfer the load to the subsoil. So giving the importance to the subsoil as equal to that of your foundation is very important. And you know that like for the satisfactory performance of superstructure, it is important to have the stable design of foundation, stable design of substructure. If you are failing to maintain the stability of your substructure, what possibility will be there? Your superstructure will fail to maintain its stability. The stability of superstructure is mainly depends on the stability of substructure. But due to lack of knowledge, due to lack of experience, we are not giving importance to the substructure. We are not giving the study of the substructures. We are taking it very light, but it is having the more importance than that of your superstructure. Sometimes the practitioners and all the persons who are beginners in the field of structural design, they are comfort to design the superstructure, like whatever the elements coming in the superstructure, like beam, column, slab, shear wall, whatever the elements are there in the superstructure, they are comfort to design those all elements. But they are lagging, they are having the less confidence, they are less knowledge, they are less confidence to design a stable substructure, a stable foundation. And sometimes your stability will be there, but you are losing your economy. You are making your design as uneconomical. Sometimes, okay, some persons, they are knowing the importance of substructure, they are knowing the importance of foundations of design. They are unnecessarily going to make the very, very heavy design. Unnecessarily, it is going to increase the cost of your construction. So stability is very important along with the economy. if you are going to make your design very stable, very safe, but ultimately it is going to become uneconomical. So economy along with the stability is very important. Both the things should be in equal proportion, should be in adequate proportion. Stability along with your economy, both the things are very important. So as I told you, beginners in the field of structural engineers, they are comfort to design the superstructure, but due to lack of knowledge, lack of confidence, dealing with their real life projects for the design of substructure, they are having so many doubts, so many confusions in their mind. They are having the fear to design of substructure. There are so many confusing questions. There are so many doubts in their mind. What are those? Let's try to understand. Sometimes the beginners are asking about what are the different types of the foundations. We are knowing only the very limited number types of foundation, like isolated foundation, pad footing, or box footing is there. No, that is not only the type of foundation. There are so many different types of foundations. In isolated, what different types of foundations are there? Like pad footing is there, stepped footing is there, slope footing is there, eccentric footing is there. There are so many types of footing. In our academics, we generally have learned only design of your isolated pad footing. But what about others? We are not knowing the concept of designing of all those types of foundation. Strap footing, what does it mean by the strap footing? In which condition this strap footing we have to use? So what are the different type of foundation is very important to know. In what condition a particular type of foundation to be selected? Like suppose if I'm giving if I'm giving the site condition with a particular bearing capacity of the soil, so what type of footing you have to choose for a particular loading? There are so many different types of footings. There are so many different categories of the soil conditions. There are so many there may be different bearing capacities of the soil. So under particular situation over which you are going to deal your structure, what type of footing will be suitable? Is sometimes the participants are asking about, or students are asking about, is the selection of particular type of footing depends on the bearing capacity of soil? Obviously, and that is important to know whether the type of footing is depends on the bearing capacity of soil or not. Then what does mean by the soil investigation report? Most of the times we are not knowing what does the soil investigation report, what is the importance of soil investigation report, okay, how to read the soil investigation report, whether it is sometimes they are asking about what it is needed to perform the soil investigation for all the structure. Like if suppose I am going to deal a small structure, so it is important to perform the soil investigation. If I am dealing the medium rise structure, it is important to perform the media soil investigation report. If I am going to deal with the high rise structure, it is important to do the soil investigation. So for which structure, for which condition, it is important to go with the soil investigation. That's important to know. And students are not students and beginners in the field of structural design, they don't know where to perform the soil investigation. Like suppose I'm giving the site, so at what location you have to perform the soil testing, what methods you need to adopt, who will tell you? Who will tell you? Either soil investigator or geotechnical engineer will decide the position of the testing, or structural engineer will give us some suggestion or not. On what basis the structural engineer will give the suggestion to perform the testing at a particular site at particular point? So who means it is important to know what are the content of soil investigation report, how to read this report, how to find out the bearing capacity of the soil from that report, what content will be there, what methods of investigation will be there, what are the different types of the soil different methods of soil investigation, how I can design all types of footing manually or by using spreadsheets. If you are going to work in any consultancies, so what methods they are following? Either they are doing the design of foundation manually, or by using spreadsheets, or by using any softwares. So software, you know very well, it's just a software. If you are giving the wrong input, software will give you wrong output. If you are giving the right input, software will give you right output. But software will do the everything. If the software is doing some mistakes, so how you can validate that? How you can check that? So having the knowledge of doing all these things manually is very important. And manually in the structural design field terms means as dealing with all these types of foundation by using spreadsheet, by using Excel sheets. So it is very important, very, very important to have the base, to have the firm base, firm knowledge. Which software I can use for the design of which software I can use for the design of all these types of footing. If suppose I have to design the pad footing, so I can use the software. If I have to design the strap footing, can I use the this software? Which software I should use to design the strap footing? If I have to design the combined foundation, what type of footing I have to choose? If I have to design the raft foundation, pile foundation, any type of footing, what software I should take? What steps I need to take for the design of any real life project completely from start to end? From start to end for the design of substructure, what steps I should take? How I can prepare the schedule, how to prepare the layout, how to prepare finally design report. No one will tell you, no one will teach you about these all things. These all things are very practical, and that is important to know. And having the knowledge of these all things is nothing but your experience, adding confidence to yourself. Can we trust on the software results? And how I can validate it? As I told you, if you are having this, if you are having the basic knowledge, basic manual calculations, and basic concept is very clear, then you can use the software and you can validate the software, and your result will be reliable. Your result will be validate result. Your result can be means accurate. That can, as per your result, we can execute the projects. So these all are the very, very important questions and the doubts, and always almost the beginners and practitioners, beginner in the field of structural engineer, they are having, they are asking, they are not knowing. So to answer all of these questions, we have prepared this training program. By just looking over the industry demand and current scenario, we have prepared this training program. So here we are going to cover all these requirements, all these needs to make you a professional structural engineer for the design of substructure. So all these requirements we have added here. In this training program, we are going to cover all those things. And this training program is going to start from 2nd of June. And here we are going to take live sessions. So live interaction will be there. Your doubts, your queries, you can put here. All the materials we have prepared for your practice, for your understanding, like PDFs are there, manual calculation sheets are PDFs are there, Excel sheets are there, and then SAFE software will be there. So all these things we are going to combine in once. You don't need to look anywhere. Once you complete this training program, you will have the confidence to design any real life project for the design of foundation. All types of foundation here we are going to cover, like isolated foundation, step footing, slope footing, raft foundation, pile foundation. Individually we will deal all this type of footing. Then we will go to deal with a real life project. So here we are going to cover 4 real life projects. Can you imagine? 4 real life projects that will cover all types of foundation. Live sessions will be there, and continuous assessment will also be there. One more thing we are going to add here in comparison of our previous program. In the first program of ETAPS RCDC Excel, one more thing here we are going to add as continuous assessment. We will give some task, you have to complete that. We will check that. So here only the learning will not be there. Here with the experience you will get. The continuous assessment, continuous task will be there. Got it? So this training program is going to be completed in 3 sections. Hello, am I audible?
Yes, sir. Yes, sir.
Okay. So this complete training program is going to be completed in 3 sections. In the first section, we will cover all the basic concepts of substructure design. What does mean the bearing capacity of the soil? What does mean the pressure bulb? What is the importance of having the knowledge of pressure bulb? What type of the foundations are there? What is the flexural behavior of your structure under the loading? How to schedule the individual type of footing, how to design the positions of the reinforcement. There will be a brief discussion about what all the concepts of substructural design, and so many things will be there. Then there is the design of all types of footing manually. Step by step, I will let you know how to design the all types of footing. Like this kind of content we are having, I will let you know step by step how you can design the isolated rectangular footing, isolated stepped footing, box footing, okay, along with the scheduling and detailing. Everything you are going to learn from this training program. Isolated rectangular footing will be there. Then what will be what include in this like stepped footing will also be there. Step by step I will let you know how to design it, how to schedule it, how to detail it, and how all the practical points we will cover here. Not only the basic things, not only the as similar that of your academics, we are not going to study here. All the things we will learn practically. Under which situation you have to use the step footing, like isolated foundation is there, box footing is there. So in for what purpose we are going to look stepped footing, for what purpose we are going to look at the sloped footing, when to use this sloped footing, whether it will add the stability to your design, or it will add the economy to your design. What will be there to choose for the stepped footing and sloped footing, that we'll discuss in detail. Then combined footing will be there. Raft combined footing, strap footing will be there. Under which situation strap footing you have to choose, what how to do the scheduling and detailing. Everything we will discuss in detail manually. I will let you know all to do all these things manually. Then one more thing we are going to add here as design of basement wall. If you are going to, if your structure is going to be satisfied with a Raft foundation, if suppose the basement is there, so you know that if the basement is there, so basement wall anyhow you need to design to retain the wall, surrounding wall. So that is important, that is the part of your substructure, and that's why we are going to include here. So design detailed schedule of basement wall we will cover in detail in this training program. In detail we will cover how to detail the basement wall, how to schedule the basement wall, how to design this basement wall. Okay, all types of footing manually we are going to cover here. In the second step, we are going to cover all this design of footing by spreadsheets. Actually taking this manual calculation just for your understanding. In your academy you might not have done all these things manually, but here we are going to deal all this type of footing using spreadsheets. Like how simple box footing, pad footing, then designing of all this type of footing using this stepped footing, then how to design this type of sloped footing, how to schedule it. So in a very short period of time you will have the design schedule along with detailing. Thereafter, the sheet we are having the sheet for the design of combined footing. Under which situation we have to go with the combined footing. Under which situation we have to go with the strap footing. That for that sheet for that purpose we are having the sheets for the design of pile foundation, pile cap, for the 2 pile, 4 pile, 3 pile, 6 piles. All for all this type of pile caps design we are having the Excel sheets. So here all these things is going to be covered. Try to understand. So like design of all types of footing bags, spreadsheets. Thereafter, after completion of these things, and along with all these things, side by side, we will learn about all the basics of CSI SAFE software. What is the basics of CSI SAFE software? It's the commands. So many things will there. And the fifth point, the most important of this first section is what? Validating the result of CSI SAFE software for all these different types of footing. I will let you know whether the results of your manual calculation or the results of your Excel sheets, whether it will match with CSI Safe software or not. Most of the time students are or participants or beginners in the field of structural engineering, they are using the software, they are learning the software from the any other modes, like any other platforms like YouTube, they are learning. But after completion of that videos, that tutorial, they are not having the confidence whether my design is right or wrong. So I will show you one calculation by manual or by spreadsheets, and that same thing we are going to execute in the CSI Safe software, and we will match the result for all the types of footing. And once you get the your manual calculation to be validated with or your software result to be validated with your manual calculation to each other, then you will come to know my result is right, and I'm means sure about my results. Getting? So this will be over your first section, and the output of this, after completion of this first section, you will have the confidence. You will have the confidence of design of all types of footing, along with the confidence of dealing with the CSI Safe software. And this first section will make you comfort to design a foundation, design substructure. Thereafter the next section will start. There we will start real life project. There will start what? Real life project. So how to start, how to initiate any real life project, what important things you need to have to start any real life project, what knowledge you need to have to start a real life project, what steps you need to follow for the completion of any real life project. So not 1, 2, 3, here we are going to cover 4 real life projects. Got it? See what steps. So for dealing the real life project, very first thing that you need to have the soil investigation report. So here we are having the soil investigation report, like for all the projects, the concerned real life project and concerned geotechnical report we will study. The content, what are the content of geotechnical report, how to read this geotechnical report, how to find out the bearing capacity of the bearing capacity of the soil for the proposed structure, for the proposed location, for the proposed land, for the proposed structure. What are the tests will be included in geotechnical report, how to convert the bearing capacity from ton to kg to kilonewton per meter square. Okay, how much we have to consider. Okay, so brief study about geotechnical report will be there. Brief study about will be there. So and it is very important to know. Got it? After that, the next step will be what? Let me show you. In the next step, modeling of structure. Actually, the first data for the design of the foundation is what? We need to have the capacity of your subsoil. The second requirement is what? We need to have the base reaction. We need to have the load that is coming under the particular point, the load coming under the particular column, the load coming under the particular shear wall. Means what loads overall is going to be concentrated at the base, at the soil level. So we need to do the modeling of the structure, performing the analysis, and finally our intention is what? To know the load coming at the base of your structure, that is we are calling it as base reaction. So at the base we need to have the base reaction. So what base reaction we are having, that we are trying to know, and after having the soil investigation report and bearing capacity, and after having the base reaction, you can proceed for the design of the you are ready for the next step. So in the next step, what you need to do, you have to decide the type of footing, what type of footing you should take for your proposed site condition, or for the bearing capacity of the soil and upcoming load. So in this training program, we will discuss about for what intensity, what type of footing you have to take, for what bearing capacity of the soil, what type of footing you should take. That will discuss in detail. So many types of footing is there. Once you go through this all 3 steps, and you complete this all 3 steps, the fourth steps will come into the picture. That is what we have to deal with the software. We have to deal with the software, like what materials we have to use, what footing area we have to use, what depth we have to we need to have. Then serviceability checks will be there in settlement, in upward soil pressure. So many things will be there. And once your analysis is right, or all the checks is okay, then you go for the design of the reinforcement, flexural design, shear design, scheduling and detailing. Everything we need to do, everything we need to do. So here what we will cover, like the software we will take. The first real life project, in the first real life project, all types of footing we are going to means all possible types of footing that is needed to under the particular loading, for the particular soil condition, bearing capacity of soil, whatever the type of footing will be suitable, we will choose and we are going to design it. So this is the project we will deal. Then another project we will deal, that will cover stepped footing. Then raft foundation will be there, and pile foundation with there. So very complicated structure we are going to deal here, so that in future any kind of structure if you are going to deal, so you should be able to design that type of foundation. So here, how to define the material properties, how to define the slab properties, how to define the strap beams, how to define what does mean by the point spring stiffness constant, soil subgrade reactions, line subgrade reaction, and point subgrade reaction. The soil properties here is defined by what? Soil subgrade properties, point spring properties, line spring properties. How to define it? How to define it? We will discuss in detail. In very detail, we are going to cover. What does mean by the design strip? In the CSI SAFE software, there are two types of methods of design of any plate element or foundation element. One is your strap beam, strip method. Another one is your finite element based method. So what is the difference between these two methods? What will be the difference in the results? What will happen if you are going to design your foundation by strip based method or by using finite element based method? How to means see the results. Okay, how to see the analysis result, how to see the design result, how to find the percentage of reinforcement, how to see the minimum percentage of reinforcement where shown by the software, how to see the maximum percentage of reinforcement. So many things we will discuss here. How to check the upward soil pressure, how to check the settlement, for what should be the settlement of your shallow foundation, what should be the settlement of your deep foundation, like a simple isolated box footing, raft foundation, pile raft foundation, and combined footing, strap footing. If you are going to deal, what is the allowable settlement? If you are going to deal with the deep foundation, like a pile foundation, what is the allowable settlement? Who will tell you what is the allowable settlement? Who will tell you? So that we will discuss in detail. Where that settlement, allowable settlement, will be given in your soil investigation report. Okay, so where it is given, how you will come to know where it is given in the soil investigation report, how to find that, I will let you know in detail. Overall, after that, we have to check the whether your design, your depth is safe in one-way shear or two-way shear or not. So most of the time in tutorials and from other trainings, you will get the punching shear, but no one will tell you how you can check the one-way shear. So that I will let you know how to check the one-way shear. So I suppose, or whether the punching shear is right or wrong. See, I am going to perform the punching. Just right click. So I hope some of you are knowing that if this value is less than 1, then your design is safe in one-way shear. Sorry, punching shear. So at what location you need to perform the punching shear, at what section you need to perform the one-way shear. So here, how to check whether this punching value is right or wrong. So I'm going to right click here. So the value is what? Overall depth of this this footing is 400. Overall depth of this footing is actually what? 400. So I'm going to put here as 400. Now the diameter of clear cover I am going to use here as for example 50 mm I am going to use 50 mm, and dia of bar here is, I suppose, 12 mm. So effective depth, how much it will become? So let's see, effective depth will become 400 minus 50 minus half of your diameter, that will become 6. So how much it will become? 344. You can check it, you can cross check it. 344 the value will become. So yeah, effective depth where calculated by the software is right. Effective depth where by the software is calculated is right. But effective punching perimeter is what? 3368.508. 3368.508. The value is actually present here. The effective punching perimeter. So how I can validate this? So suppose see the value is what? See at a distance of see d by 2 from the face of the column, at a distance of d by 2 from the face of your column, we are taking the punching shear. So punching shear we will take at a distance. So this is 450 and this is 230. So d by 2 from this side and d by 2 from this side, it is going to become d. So means depth is what it will become. Let me show you. Try to understand. So how much it will become? D by 2 from d by 2 from this side will become d. That means 344 plus this 230 in this direction. So 230. Okay. Multiply this with 2. Multiply this with 2 for this side and for this side. Got it? If you are talking about this side and this side, so how much? D by 2 will become d. Okay, and this also 2 times, and this what? 450. So how much it will become? Plus it will become 344 plus 450 multiply this by 2, and if you are adding this 2 value, so effective punching perimeter you should get, let me show you. This value should be, I am calculating here with my calci, like 344 plus 230 multiplied by 2 plus it is plus inside bracket 344 plus 450 multiplied by 2. So total value you are getting what? 2736. It is what? Effective perimeter, punching perimeter span. But software is giving what? 3368. It is giving what? 3368. But means your manual calculation is different and your software calculation is different. That is the problem. That is what? The problem. So how to correct it? How to correct it? How you will have the correct punching shear ratio? That I will let you know how to correct it. This is also right, it is not wrong, but if you are going to exactly match with your manual calculation, so and you want to validate it with your manual calculation, so how you can do that, I will let you know. I'm not going to discuss here right now due to time limit. Got it? So clear this all. Okay, see if 27, what value was there? 2736. So clear this. Just I'm going to check for this. Here also the same thing is there. Effective depth is 344. Right click here. Here it is calculating right 2736 because I have corrected here. I have corrected the result here. That's why we are having the correct value, so that it is very reliable value as 0.68. But here some modification is needed to correct the design. This is the first thing. Second thing, like how to check likewise whether how you can check the one-way shear, whether your design is safe in one-way shear or not. That I will let you know. One-way shear. Then in which situation you need to go with the combined footing. In which situation you need to go with the combined footing. How to design the combined footing. Then how to define the subgrade reaction, how you can assign the subgrade reaction, how you will have this extruded view. What does mean by this stiff area? Here I am not defining the column. Here as you are looking that here there is no presence of any column. Why the column is not there? In which situation you have to take the column? In which situation you can go with the stiff area? Most of you are not aware with the stiff area. What is the role of stiff area? How to define this stiff area? What will happen? What is the difference of defining the column and defining of strip area? That I will let you know. The column is not present here. Why the column is not present? What will happen here? Everything we will discuss in detail. Just go to see, like this one project we will take, another this project we are going to take. There the step the footing will be there. The project might be different. Okay, so this kind of structure we are going to discuss, like uh, step the footing is present here. Step the footing. Okay, how to model this step the footing for the shear wall area? How to decide the size of the footing? What should be the depth of steps of your step the footing? What should be the base step depth? What should be the upper step depth? How to design it? How to schedule it? Everything we will discuss in detail. How you can how you can make it as economical for the design of you can design it, you can schedule it, but how you can make it as economical? Here the normal design and detailing, but how there is an option to make it as economical. How you can make it as economical? By saving the reinforcement. Got it? That will cover in detail. Then we will take a Raft foundation in detail. Raft foundation. So how to design this Raft foundation? How to model it? Under which situation you need to go with the Raft foundation? Which situation? There we will discuss in detail. Under which situation we need to go with this Raft foundation? How to perform the analysis, how to perform the design, how to prepare the schedule, detail, everything we will cover in detail. Like this kind of study we will do, this kind of result we will prepare. So the layout of showing the position of the Raft and column. See, I will let you know how to prepare it finally, how to export the result from your software. Once the foundation is designed by the software, how you can export these results. Okay, I forgot to let you know how to export the reaction from the DAP software. That reaction we are going to import here. Once you imported that reaction, you have to do all the things in the CSI SAFE software. Once the design gets ready, you have to export the design result, design layout, final area of the footing in the CAD drawing. So how to export it? Then how to prepare the schedule, how to export and how to correct the imported drawing. Then how to prepare the schedule, under which column, what size, what for a particular column, how much reinforcement is required, how much shear reinforcement is required. That we'll discuss in detail. That will discuss what in detail. The column layout you have to put up. Then detailing of the footing you need to do for the bottom reinforcement. For the Raft foundation, the reinforcement will be present at the bottom also, at the top also. Under which situation the top reinforcement will be there, under which situation the bottom reinforcement will be there. Okay, there was a brief discussion where to provide the lapping, anywhere you can't provide the lapping. So how to decide the position of lapping, how you can get from the software that lapping. Okay, how to design the lapping based on how to decide the position of lapping based on strip based method. See, this is what the result, and showing the reinforcement, where to how to find where the reinforcement is required at the bottom, and how you can find the reinforcement required at the top. How you will come to know from this software, that discuss in detail. I will let you know. Okay, everything, whether the software is following the minimum reinforcement criteria or not. Everything we will discuss in detail. Okay, thereafter we will prepare the final schedule. Like this is what layout of showing the top reinforcement. It's a section you have to show, so that your site can be executed with these your drawing sheets. So that is also included here. And in the last, the most important type of foundation we are going to cover, that is what your pile and pile cap foundation. Pile foundation. So for the design of pile or pile foundation, we need to design the pile cap also. So what is actually the importance of the pile cap? how to design the pile cap, and what are the different shapes of the pile caps, how to decide the number of piles under any pile cap, on what parameters the number of piles under any pile cap is depends. Okay, under which situation you need to go with the pile foundation or pile cap design. So there is a brief discussion about that. Can we use different die of pile in one project? Okay, in under one pile cap, how many number of maximum piles you can take? What will happen if you are taking 2 piles? What will happen if you are taking 3 piles? How to make the design of pile cap as safe? So I will let you know by manual approach, by using the spreadsheets. So everything we will discuss. Okay, then we will prepare final. So this is what in the second like in the second section, you are having the after completion of the second section, you will have the confidence of dealing the real life project, designing it with the software and exporting the result from the software, and preparing the final schedule and detail box in CAD software. Thereafter, finally, we are going to prepare the layout of your design result that you have to export, that you have to send on site for the site execution. So final design sheet, how to prepare, that I will let you know in this training program. Like this, suppose how to set the layout, and how to set the final design sheets. Final design sheet I will let you know. Then here it is what bottom reinforcement, how to prepare it, how to give the label to all the columns, all the reinforcements, and so many things are there, we will discuss in detail. And finally in the last, this kind of report we are preparing, and finally we are preparing the PDF for the site execution. Like this is what your final design sheet for all the foundations. Final detailing, how to do the detailing, how to put in the layout, final layout. Okay, everything we will cover for the pile cap, for the pile foundation. Everything will be covered in detail, and once the training will be completed, you will get the ISO certification, government approved certificate you will get. So this is what total content of this training program. And in this also I have told you, if you are going to design the raft foundation, or basement is there in your structure below the ground, so you need to design the basement wall. So that is also included here. For the design of basement wall, we will have this sheet, and I will let you know how to design, how to schedule, how to detail. Everything we will discuss in detail. So this is about overall content of this training program. So in this way, we are going to cover all the things we are included in that we have planned to cover in this training program. Is that all okay? So this is all about this training program and the content. Now you can ask your question, whatever you are having the doubts. Hello, and so many other things are also there. Okay, but due to time constraint, I can't show you. Okay, so we first, as I told you, we will validate the results with the manual and your software. So that is very important step. Okay, so remember this. Means after having this training program, you don't need to look anywhere. Everything will be covered, and registration has been started. You can book your seat. You can contact me at this given number 8857891345. Anytime you can WhatsApp me, call me. Daily live sessions will be there in evening from 8 to 9:30. So the training is going to start from 2nd of June. Before of that, you have to complete your registration. Registration has been started. You can pay the fee at 8857891345 through GPay, PhonePe, Paytm, whatever the mode you would like to have. Through that, you can pay the fee 8857891345. Once you done the payment, send me the screenshot. You will ask some basic details, then your registration will be done, your seat will be booked, and you will be allowed for the session for the training. Safe software we will provide, everything we will provide, seats we will provide, everything that is needed for your study, for your learning, for your understanding, everything will be shared.